that we understand how and when to use EQS, let's build something a little bit more complicated. In this video, we will create a query that will locate valid positions that are as close as possible to the player, but at the same time, avoid line of sight with them. This is the sort of behavior that could later be developed into an ambush behavior, and also allows us to see the power of user-created context within EQS queries. We'll begin by creating a new context. This new query is going to need to make some decisions from the position of the player character, but we don't currently have a usable context for that. We'll begin by creating one and then work that into our new EQS query. Right-click in the content browser and go to Blueprint Class. Expand the All Classes rollout if it's not already open, and search for env query context _ blueprint base. When that's created, name it EQSC _ player. Next, create a new folder within the EQS folder and call it Contexts. Place our newly created context inside this folder and then double-click to open it. The purpose of this context is to locate the player character and supply that as the new actor. We can do this by overriding an existing function. Hover over the Functions section in the My Blueprint panel and then select Override, and then select Provide Single Actor. Now we just need to add something that will find the player character within our level. We can do that very easily by right-clicking within the graph and locating the getPlayerCharacter function. Connect the return value of this to the resulting actor of the return node of this function. Luckily, that's all we need to do for this new query. Compile and save the blueprint and close the blueprint editor. Now we have access to the player character via the new context we created, we can create our new query. While in the EQS folder, right-click in the content browser and select Artificial Intelligence Environment Query. Name this new query EQS _ hide near player. Double-click to open the editor. Our starting point for this query should be a number of points surrounding the AI. Then, after running a series of tests, we can gradually reduce that number of points to a single point. Luckily, a generator already exists to generate a grid of points. Drag out from the root node and select Points Grid. Now we just need to make a few adjustments to this grid to make it more suitable for the size of our level. A larger, more sparse grid is more suitable for this task. Moving over to the Details panel, change the grid half size to 1200 and the space between value to 300. Ensure that these points will be positioned around the AI character that runs the query by ensuring that the generate around value is set to env query context _ querier. Now we can start to filter this grid by first removing all the points that would make the AI visible to the player if they move there. Right-click on the generator and select Add Test. Then select Trace. Left-click on this test and move over to the Details panel. Firstly, select Filter Only. We do this because this test won't help us decide on the best point, only those that are completely invalid. In the Trace rollout, move to the Context section and select our newly created EQSC _ player. This means that the test will now attempt to draw a trace from the position of the player character to the position on the grid, and if that point is a hit, that point will be filtered from the list of potential valid grid points. That's a good start, but we still need to apply additional filters. From those remaining points then, we want to pick the one that is closest to the player. Right-click and select Add Test, and then select Distance. Left-click to select the test and move over to the Details panel. This time, ensure that the test purpose is set to Score Only. In the Score section, locate the scoring factor and change it from a value of 1 to -1. This will invert the scoring and mean that lesser distances are preferred. We can confirm this by moving back to the test in the graph and seeing it now says Prefer Lesser. We have selected scoring only at this stage because we do not want to discard any points. It is possible that the highest scoring point could fail our next test, and if we discarded any lower scoring items at this point, we may end up with no valid points at the end of the query. The final test that we need to make is to make sure that the AI can actually reach this point. That is to say that they can generate a path from where they are to the point using the nav mesh. Right-click once more and select Add Test. and then use the pathfinding option. Left-click this test and move over to the Details panel on the right-hand side. Double-check that the context is once again set to env query context_querier, as it's the AI itself that needs to make sure it can navigate to this position. Also, in this instance, we do want the test purpose to be filter and score. As this is our final test, we wish to be left with one single result, which in turn will be where the AI will move to. With those 3 tests configured, this query is complete. We can save and close the window. With our new context and query created, it's time to add it to the behavior tree. Navigate to the bt_assets folder and open the behavior tree. We are going to modify our existing chase player sequence and turn it into a hide from player sequence. Begin by marquee selecting the existing sequence and moving it over to the left to give us a bit more space. Left click to select the sequence and change the node name from chase player to hide from player. The first thing this new sequence needs to do is run the query to find a location that is hidden from the player. We will do this by running our new EQS query as the first task in the sequence. Right-click on an empty space within the graph and then select Run EQS Query from the Tasks section. Position this new task on the far left-hand side of our sequence, as we want this task to be run first within the sequence. Drag from the sequence to the query. The purpose of this task is to give the AI a new location to move to, rather than an actor that it was moving to before. That means we will be manipulating a different Blackboard key. Within the Details panel, locate the Blackboard rollout and change the Blackboard key from self actor to target location. We also need to specify our new EQS query. In the EQS rollout, select our newly created EQS_hide near player environment query. Next, select the Move To task. Currently, this is configured to move to a target actor, but now we would rather it move to a target location, specifically the target location Blackboard key we've just defined in the previous task. In the Details panel, within the Blackboard rollout, change the Blackboard key from target actor to target location. Use the marquee select to reposition the nodes to keep everything neat and tidy. Let's quickly review the changes we have made and the impact that will have. Firstly, we haven't changed the decorator. This hide from player sequence will only be triggered when a target actor is set. The only thing that can set the target actor is the logic we've configured following a perception event. Assuming the player character is successfully perceived, we will run the hide from player sequence. The sequence will begin by running our EQS query, EQS_hide near player. This will return a single point that is invisible to the player, close to the player, and reachable by the AI using the navigation mesh. The single highest scoring point will be returned by this query. It will then be used to set the target location Blackboard key. Once that successfully completes, the Move To task will move to this target location Blackboard key. Once it arrives at that location, it will wait 1 second. With our changes to the behavior tree complete and reviewed, we can save and close the behavior tree window. In this video, we built a more complicated EQS query for the AI to use. We created a new context that defined the player character and used that information, combined with some other techniques, to locate valid positions that are as close to the player as possible while still breaking line of sight. We learned that by combining several simple generators with a new context, we can quickly make surprisingly complex queries via the EQS editor.